This is RD Sharma solution class 12th. We are taking probability chapter and the exercise is the second exercise. A card is drawn from a well shuffled deck of 52 cards and then a second card is drawn. Find the probability that the first card is a heart and the second card is a diamond if the first card is not replaced. So in all, in 52 card, we have 4 suites: spade, club, diamond and a heart. Now all of them are 13 cards. So if you multiply 13 by 4, it will be 52 cards. So there are 13 diamonds and 13 hearts. The question is asking about these two only. So the first event we are going to make, the first card being drawn is a heart. Our first draw gives us a heart. And the second event will be second card being drawn comes out to be a diamond. Please remember that the first card is not being replaced. What is the probability of getting a heart? So we have the total number of cases because there are 52 cards, so it goes in the denominator, and probability of getting a heart, which is the 13 numbers. So 13 by 52 is 1 by 4. Now probability of getting the diamond in the second draw, but we are aware that the first card has already turned out to be a heart, and since they both are different cards, we are left with 13 diamond, but one card has been taken out which comes out to be heart, so we are having 52 minus 1, that is 51 cards in all. So taking out a heart does not affect the diamond. The diamond will remain as 13 only, so 13 will be the total number of favorable cases. So the probability of getting heart and then a diamond is A intersection B, and this will be equal to probability of A, that is probability of the first card multiplied by this probability of getting a second card. So PA into PB by A. So this will be 1 by 4 multiplied by 13 by 51, and this comes out to be 13 by 204. Now this is how it is going to be written, and this is a formal way of doing it. An urn, you can understand it as a container or a box. It contains 10 black and 5 white balls. So let's make a box, and inside this we have 10 black and 5 white balls. This is 10 black and 5 white balls. Just make it like this, 5 white balls. Now 2 balls are drawn from the urn, one after the other without replacement. First we took the first ball and then the second ball. What is the probability that both drawn balls are black? First time the black should come and second time also the black must appear. So in the first draw, black appears, and in the second draw, again black appears. Now 5 plus 10 is what? Its total balls are 15. We haven't started drawing as of now. Initially 10 plus 5 is total number of favorable cases are 15. Now probability of getting a black in the first case, 15 will be the whole number, total number of cases. But there are only 10 black balls, so the favorable cases will be 10. So 10 divided by 15 is 2 by 3. Now what is the probability of getting black in the second draw? But we are aware that first black has already come. But in all there were 15 balls earlier. Now you subtract 1 because 1 has already been taken out. So 14 will remain. 14 will be the total number of cases. Now there were 10 black. 1 was already being drawn in the earlier drawing of the ball. So 10 minus 1 is 9. Only 9 balls which are black are left. So these are the favorable cases. So probability of getting the first ball as the black and the second also as black is PA intersection B, and this will be 2 by 3 multiplied by 9 by 14. When you multiply, it will be 3 by 7. So this is how it will be done. Okay, 3 cards are drawn successively without replacement from a pack of 52 well shuffled cards. What is the probability that the first 2 cards are kings and third card drawn is an ace? Now in all there are 52 cards. 4 cards are king, these are kings, 4 of them, and 4 of them are ace, 1 each from each suite. So we are picking 2 cards of kings and third card as an ace. So A will be the event of first card being drawn comes out to be a queen, second one coming out again as the king, second draw also provides you king, and C, the third one, it comes out to be an ace. So probability of getting the king, there are in all 52 cards, so total number of cases are 52. Now king is what? 1. 4, sorry. So there are 4 kings, so any of them can come. 4 by 52 is the probability of getting the king in the first go. Now second go, first is already known that king has come. So 4 minus 1, only 3 are left now. So only 3 favorable cases are there, and in 52 cards, 1 has already been drawn, which comes out to be a king. So 52 minus 1, 51 is the total number of cases. 3 by 51 is 1 by 17. And probability of getting the third card as an ace. So A intersection B will be the already known case. So knowing that king has already come and then a king has come, what is the probability of getting an ace? Now 52 are there, then we got a king, then again 51, then we got a king. So 50 are left now. Now A's are still 4. They haven't changed. A's are still like this. So 4 will be the favorable cases. So 2 by 25 is the probability of getting an ace. So probability of getting all of them in tandem is A intersection B intersection C. So 1 by 13 multiplied by 1 by 17 and multiplied by 2 by 25 is going to be 3 by 5525, 5525. Now this formula is very important, and you know that all these 3, PA into PB by A into PC by A intersection B, these 3 needs to be multiplied, and we multiply these in order to get the desired result. A box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. So there is a box. Now in this box we have oranges. So it is a quality assurance and quality control kind of question. That is, if all the 3 oranges are good, the box will be approved for sale. Otherwise the box will be stopped. It will not be sent for the sale. So first, second, third, 3 oranges were drawn one by one. If all of them 3 returns out to be good, that is, they are not stale, they are not bad, so the approval can be done. Now find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad, will be approved for sale. So again, the approval will only be done when all of the 3 comes out to be good ones. So in all there are 15 oranges. So total number of cases for us are 12 in the beginning, 15 in the beginning, and 12 are the good ones. So 12 are the favorable cases in the beginning. So 12 are good and 3 are bad. Now let's make the event. There has to be 3 events because 3 oranges are being picked one by one. So first, a good oranges or orange comes out in the first draw. Then in the second drawing, first was not being replaced, a good orange turns out in the second draw. And third one is C. Again, a good orange has come in the third draw. So probability of getting the good orange in the first draw, as I suggested, total number of cases are 15 in the beginning. 12 oranges are good oranges, so these are our favorable cases, and this is the probability of good orange at the first draw. Now probability of getting B and probability of getting C, that is probability of getting good orange in the second draw, will be what? Just subtract 1 from numerator and denominator because 1 has been taken out. So 15, 1 was taken out, 14 is left. In good oranges, 1 was taken out, 11 is left. 11 by 14 is the probability of getting good orange in the second draw. Now probability of getting the orange in the third draw, a good orange. Again subtract 11 minus 1 is 10, 14 minus 1 is 13. So probability of getting B is simply by knowing that A has already come. The probability of getting C is after knowing that A and B both has come. So this comes out to be P A intersection B intersection C, that is all of the 3 oranges being drawn are good. Is simply on the left I have written these 3 probabilities, just multiply these 3 like this. You need to write the formula, remember. So this will be 4 by 5 multiplied by 11 by 14 multiplied by 10 by 13, and this comes out to be 44 by 91. This is the probability that the box will be approved for sale, which is filled with oranges. So this is a very simple question if you just see the solution, but it needs a lot of logic as far as the solution of probability wise is concerned, a bag contains 4 white, 7 black and 5 red balls. So 4 white I am making now, 7 black and 5 red balls. 4 white, 7 black and 5 red. Now this is inside a box. 3 balls are drawn one after the other without replacement. Now the ball drawns are white, black and red. So one time, the first time it should come as white. Second time it should come as black, known that first previously white has come, and probability of getting a red when it is known that white and black has already appeared. So these are the 3 probability. I'm writing it in terms of W, B and R just to let you know that we are talking about white, black and red balls. But actually, we write A, B, C. This is the trivial and traditional way of solving the probability. Now let's make the event for the first one. The first one, the event comes out to be a white comes out in the first draw. The first draw produces a white ball. Second one is the second draw produces the black ball. The third one says that in the third pick, the ball appeared as a red ball. Now let's make the probability here PA, the first probability. Total number of cases are what? 4 plus 7 plus 5. 7 plus 5 is 12 and 12 plus 4 is 16. The total number of cases are 16. I'm just adding these 3. In 4 whites, any can come. So 4 by 16 because 4 are whites. 1 by 4. Probability of getting the black ball. But now in 16 ball, 1 has already been taken. So 15 are the total number of cases. 16 minus 1 is 15. But the black ball remains unchanged because the first ball came as the white ball. So we are having all the 4 ball at our disposal. So 7 by 15. Now probability of getting the red ball. Now this getting a red ball again, because there are 15 ball left and 1 more has been taken out. Previously it was 16, white was taken out, it became 15, black was taken out, so it will become 14. So I'm subtracting 1 again because 1 has been taken out. So 14 in all is there, but in our favorable cases term, we are going to get the red ball which is expected in this question. So 5 are still left. This 5 are. So 5 divided by 14. So probability of A intersection B intersection C, first white, second black, third red, is going to be multiplication of these 3. This will be 1 by 4 multiplied by 7 by 15 multiplied by 5 by 14. And this is equal to 1 by 24. Now this is how this can be done. Kindly make the diagram wherever possible. All other things are quite clear to you now. So this is all about this exercise. Thank you so much. Have a good one.